All right, everybody. This is homework number. Oh, I already started. This is homework number 11. Let's go ahead and dive in. We are getting really, really close to the end. So, here are practice problems that we go over weekly, so that you can it can help you along with your work. Uh, a big note of this problem and of all these problems is that the figure is not drawn to scale. So don't let that throw you off. Just follow the formulas. So here we go. Consider a triangle ABC is like the one below. Suppose that A is equal to 25. I'm going to write in orange this time so that we can see it. So big A is 25 degrees. Little a is 34 units. And big B is 128 degrees. Obviously, that's not 128 degrees. Okay? So solve the triangle. When they say solve it, we want to know big C, little b. All right, so go back to our favorite blue. Okay, we know that from our formulae that we've looked at, sine of big A over little a is equal to sine of big B over little b is equal to sine of big C over little c. When you do these, we'll do them kind of in stages or in steps. You want to use what you are given to solve the problem. You don't use kind of your intermediate calculations unless you have to. All right, so let's go. So sine of 25 degrees over 34 is equal to, we'll do little b first, sine of 128, which is degrees, over little b. Okay, this is a proportion, so we are going to cross multiply. So b sine of 25 degrees is equal to 34 sine of 128 degrees. Okay, again, we're trying to limit intermediate calculations, so we're going to divide both by sine of 25 degrees. Sine of 25 degrees. Boom, boom. So b, little b, is equal to 34 sine of 128 degrees over sine of 25 degrees, which you can put in your calculator just like that. Okay, depending on which one you have. So 30, of note, make sure that your calculator is in degrees, because if it's in radians, it's not going to be right. 34 sine of 128, and that's over sine of 25. And I end up with 63.39, and the answer's around to the nearest tenth. So B is equal to 60, or little b is equal to 63.4, because 396 rounds to 4. So we have little b down. Now, to get big C, we're going to find out what big C is and use that to calculate little c. So we know that a triangle equals 180 degrees total. So 128 plus 25 is 153 degrees. And if you subtract that from 180, you get 27. So big C is 27 degrees. So it means that sine of 25 degrees over 34 is going to equal sine of 27 degrees over little c. Okay, if you look at the pattern here, then we can skip a few steps and see that sine of little c, well, little c is going to be equal to 34 sine of 7 degrees. Let's fix that. Sine of 27 degrees over sine of 25 degrees. Again, skipping a few steps. Let me know if you need me to work that out, but it follows the same pattern as the one before. Okay, so let me bring this back up. So now it's 34 sine of 27 degrees over sine of 25. and I get little c is equal to 36.523, which is just 5. So that's little c, that's little b, and this is big C. And we're done with this problem. Not bad. Not bad. Keep it organized. Let's keep going. All right. This figure, again, is not to scale, which I'll be honest with you, this kind of threw me off when I was solving the problem. All right. So little b is 36. Little c is 43. And big B is 29 degrees. Now, first off, we notice something. We have, this is a side-side angle situation where you have two sides in a non-included angle. All right, this is the ambiguous case. We don't like this, but it is what it is. This is how we do it. So we're going to use the, excuse me, we're going to use the law of sines because we have something across from something else, a side and an angle that are across from each other. So we're going to use this and we're going to wrap the ambiguous case in that. So let's go ahead and get it. So the formula is above, but sine of 29 degrees over 36 is equal to the one we have, sine of big C over 43. Okay. So little mathy math, 43 sine of 29 degrees over 36 is equal to sine of C. So that means that the arc sine of 43 sine of 29 degrees over 36 is going to give us C. Now, what this C, whatever we get for this C is going to be very important because it may be possible that it's ambiguous. So let's do a little calculation. So I'm going to do the arc sine of fraction 43 sine of 29 degrees over 36. And I get C being equal to 35.38, so on and so forth. Okay. Now, if I do 180 minus this answer, this lets me know if I have an ambiguous case or not. Boom. I do. Because if I do 180 minus that, I get 144.61, so on and so forth. Well, let's just say 6142, because they say due to the, intermediate to 4 decimal places. So that would be 3857. So we have two cases. C can be either one of these and make this work. So what that means is we have to calculate, boom, we have to calculate, so we got C. We have two cases of that. So now we have to calculate big A for both of these instances, and we have to calculate little a for both of these instances. Okay? So C can be either one of those, and that is, of course, going to impact A. That's going to impact little a. So if we'll take the big, if C is the smaller one. Okay? So the smaller number plus 29, that's 64 point something. And if I subtract that from 180, I get 115 point, I'll run it to 4 places. 115.6143. Okay, when we actually give our answer what it is, we'll round to the nearest 10th. To the nearest 10th, but we're not there yet. We're still working with the stuff. Okay, if C is 144, and again, I'm using when I use my calculator, because the numbers are still in there, I use the whole number that the calculator has. I just go up and find it and bring that number down. I don't round it at all because round off error. Here it says you can round to 4 decimal places. I don't like to do that. I like to just use the number. But anyway, so if C is the bigger of the two numbers, then little a becomes 6.3857. Okay. So now we're going to use the law of signs because now we have big A. Now we're going to use the law of signs to find little a, but we have to do two of them. So sine of 29 over 36, 29 degrees over 36, is equal to sine of, this is big C. Yeah, so we'll do the first one. 35.3857. No, not that. Sine of, sorry, I lost my brain for a second there. Sine of 115.6143 over little a. Okay, if you use the pattern from last time or you're quick with algebra, then you know that little a becomes equal to 36 sine of 115.6143 over sine of 29 degrees. Okay, let's go ahead and do that. Fraction 36 sine of 115.6143, and that's over sine of 29. And I get little a is equal to, but yeah, big angle, largest side. That would be equal to 66.9584. Okay, yeah. And this is not rounded yet. We'll round when we get to the answer part. So I don't need that little thing right there. Okay, and let's change colors so we don't get confused. You can see stuff. Okay, if it's the small of the angle, sine of 29 over 36, 29 degrees over 36, is equal to sine of 6.3857 over little a. And in this case, little a is equal to 36 sine of 6.3857 over sine of 29 degrees. Yeah, that's right. Get confused. Got to stay with the angles. All right, boom. And let's go to delete 6.3857 over sine 29. And I get little a then being equal to 8.2588. Okay. So, final answers. C is equal to 35.4 or 144.6. Okay. If C is equal to 35.4, then that means that A is going to equal 115.6 or 6.4. For the larger of the values, little a becomes equal to 67.0 because it rounds, or 8.3. And that's my answers. Indeed, I don't believe in rounding to the end. This problem can be a lot. Okay. The main idea is keeping it organized. Let's go. Let's keep going. All right, mountain officials want to build a new ski lift from B to C as shown in the figure below. The distance from A to C is 1,470 feet, which is already labeled. They measure angle DAC to be 38 degrees and angle DBC to be 21 degrees. What is the distance from A to B? Round your answer to the nearest tenth of a foot. So there are many different ways. There are a few different ways that we can do it, but we are going to take the most direct way. I don't think I'm going to have any argument from that. So if you look at angle DAC, that is 38. So that means that angle BAC is 180 minus 38, which is equal to 142 degrees. And if that's 142 degrees, plus 21. Whoa, sorry about that. That means that this little angle up here is 17 degrees. That's what we really wanted because we solved for all the angles of our triangle. We want to know this. I have an angle, I have a side, I have another angle, I want the opposite side, law of sines, which is what we prefer. So the sine of 21 degrees over 1,470 is equal to the sine of 17 degrees over, we'll just call it AB. Now, we can do some cross multiplication, but there's something that just hit me that I wanted to show you. This is equivalent to 1470 over sine of 21 degrees is equal to AB over sine of 17 degrees. Well, this makes our algebra a little bit more because then we see that 1470 sine of 17 degrees over sine of 21 degrees is equal to AB. All right. It's really the same thing, but it may be easier to look at when you're doing it. So 1470 sine of 17 degrees, and that is over sine of 21 degrees, and I get, round to the nearest tenth of a foot, 1,199.3 feet. Not hard at all. Okay, remember, all the math you learned up to this point ties into what we're doing here. Number 4, consider the triangle below. Big C, 105 degrees. Little a, 40. Little b, 48. This is side angle side. We already know what we're doing with this. Law of cosines. Okay, well, we're going to do the law of cosines to solve for C. And then we're going to solve the rest of the triangle, which is what they are asking us to do. Okay, so C squared is equal to A squared plus B squared minus 2AB cosine of C. Okay, so C squared is equal to 40 squared. Okay, I'll do it right. 40 squared plus 48 squared minus 2 times 40 times 48 cosine of 105 degrees. Okay, so straight in the calculator, 40 squared plus 48 squared minus 2, 40, 48 cosine of 105. If I put that in, I get 4,897, but that is not the answer because we have to take the square root of this. If we take the square root of this, then we get, it says round to the nearest 4 places. So that means that C is about equal to 69.9847. All right, this is for we're going to use this. So we'll leave it to 4 decimal places, but when we get the answer, C is equal to the nearest tenth. Well, the nearest tenth brings it to 70. All right, so this is our answer. But this is what this one is our answer. This is the one we're going to use to do our calculations, because now we are going to do law of sines, because we now know what little c is. So, yeah, sine of 105 over 69.9847 is equal to sine of big A over little a, which is 40. All right, so 40 sine of 105 over 69.9847 is equal to the sine of A. So that means that the arc sine of all this, 40 sine of 105 degrees over 69.9847 is equal to A, which we'll go ahead and do this. This is not ambiguous because it's not side angle. 40 sine 105 over 69.9847. And I get A is equal to A, which is equal to 33.5, because we're not going to use that one anymore. All right. Green. Let's see if this is good. Yeah, we'll use that. All right. So sine of degrees. Sine of 105 over, this is not, that didn't do what I thought it was going to do. 105 over 69.9847 is equal to sine of big C, no, not C, sine of big B over 48. Okay. I'm big on patterns and connections. So we know that big B is going to equal, we used the pattern of the one before. Big B is equal to the arc sine of 48 sine of 105 degrees over 69.9847. I used this one to find this one, because we're doing the same processes, connections. So, boom, even in my calculator, I'm going to go and copy over what I did so I don't have to. So it cuts down some of my correct work. Boom. And so that means B is equal to nearest tenth, 41.5. B is 41.5. A is 33.5. C, little c is 70. And I think that we've done everything. Not hard. Stay organized. Well, there's a little bit of work, but stay organized. That's the most important part for this. Finally, an easy one. So John is flying 2 kites. All right. What's the, blah, 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 already on the graph. He has 105 feet of string out to one kite and 120 feet out to the other kite, which is shown in our graph. The angle formed between the two strings is 31 degrees, which is also shown on our graph. Find the distance between the two kites. Let's see. So c squared is equal to a squared plus b squared minus 2ab cosine of c. So that means c is going to be equal to, if I square root both sides, I'm going to go ahead and put these numbers in. C is equal to 120 squared plus 105 squared minus 120 105 cosine of 31 degrees. And the reason I went ahead and wrote it like this is because you can literally put this, what I have here, you can literally put this in your calculator like this, and you'll get the answer. So it simplifies what all you have to do. So square root of 120 squared plus 105 squared minus 2, 120, 105 cosine of 31. Boom. And I get round to the nearest tenth of a foot, 61.8 feet. 3 steps. Okay. If you need to pause and go back to this, do that. And I feel like I'm moving kind of fast. This problem was one of our better ones, so we like that. All right. Find the area of a given triangle. Area is equal to 1/2 base times height. All right, but we don't know the height. But we know that the tangent of 29 degrees is equal to, we'll call that height, is equal to 12 over height. So a little bit of algebra. Height is equal to 12 over tangent of 29 degrees. So we can go ahead and put that in. So area is equal to 1/2 12 times 12 over tangent 29 degrees, which you can put in your calculator exactly like this. I try to do that so that if you're versed in your calculator, then you can, it shows you exactly what you can put in. Like there's no extra steps. Tangent of 29. Boom. And I get rounded to the nearest tenth. Area is equal to 129.9, whatever the units are. Unit squared, because area. Okay, this problem is about knowing what you're seeing and then solving for the height and then using that. I would probably write this one down in your notes. Okay, find the area of the triangle below. This is a formula. This is a formula. The formula is area is equal to 1/2 A B cosine C, or the two sides and the cosine in between it. Not knowing this, not looking at the lecture notes, you won't know this formula, and you will get something that is close but not the right answer. Ask me how I know. So this is 1/2 5 times 3 cosine of 49 degrees. Put in our calculator. 1/2 5 3 cosine of 49, and I get, this don't look right. This doesn't look right. Did I do this right? Thought I did. I think this is right. Am I in the right mode? Degrees. I think this is right, but if it's not, then I'll follow back up with you and do a little 30-second video to show you what I did wrong. I feel like I did something wrong there. 0.92 meters squared. I feel like I did something wrong here. All right, but anyway, I'll come back to you on that. Okay, so this is a proof that we are doing. So look at the triangles and kind of fill in what you are supposed to, what you're supposed to fill in here. Okay, so sine of A is right here. the sign of that is out right over here, H over C. The sign of C right here is H over A. Well, a little math, H here is equal to C times sine A, and H over here is equal to little a sine C. Set them equal to each other. Little c sine A is equal to little a sine C. And then a little bit of dividing both sides. Sine A over A is equal to sine of C over C. And you can do that for other sides and stuff too. So that is the conclusion of this. I will look back over that area formula because that's really bugging me. I do these problems before we do them, so I know that is so I did it, and I know that I did it correctly earlier at least. So I will follow back up with you to let you know if this is right. No. Okay. We'll let that be it for now.